Hello, I'm Daniel Park, General Manager of the R&D Center at VISSEM Electronics. In this video, I will introduce the SD506A, a 144 fiber dome type fiber optic splice closure developed by VSOF Electronics. It has been designed to simplify field installation, improve internal fiber management, and provide more reliable protection for optical fiber cables. Now, let's take a closer look at what has changed and how the SD506A is installed. The first improvement is the closure locking clamp. On previous models, the clamp had to be pushed with considerable force when opening or closing the closure. The VSOF-SD506A uses an improved toggle-type locking mechanism. This allows the closure to be opened and closed more smoothly, reducing the effort required during installation and maintenance. The next improvement is the lifting eye. On previous models, the lifting point was located near the bottom section. The SD506A has an additional lifting eye integrated into the outer housing. When the closure is installed inside a manhole, lifting equipment can be connected directly to the housing. This makes it easier and safer to lift, lower, and reposition the closure during installation and maintenance. Next is the hanger mounting system. On previous models, the hanger had to be secured using both bolts and nuts. The SD506A has threaded inserts integrated into the outer housing. This allows the hanger to be attached using bolts only without requiring separate nuts. The improved design simplifies assembly, reduces the number of loose components, and improves installation efficiency in the field. Next, let's take a look at the internal structure. The SD506A features an optimized 6-tray configuration for efficient fiber management and easier maintenance. This minimizes unnecessary fiber storage and keeps the inside of the closure neat and well organized. When the splice tray cover is opened, the tube fixing section can be seen divided into separate areas. The outer section is designed for the main cable units. The two inner sections are used to secure the jumper protection tubes installed with the new jumper protection kit. The jumper protection kit was added to improve fiber routing between splice trays on conventional closures. Limited routing space could cause fibers to move between trays without a clearly defined path. This could lead to irregular fiber routing, excessive bending, and difficulty during maintenance. With the SD506A, fibers are routed through the cord protection tubes and secured to the jumper protection kit. This creates a consistent routing path and keeps the inside of the closure neat and well organized. Main cable units should be secured in the outer section, while the jumper protection tubes should be routed toward the inner section of the TM area. One jumper protection kit is installed as standard and can secure up to 12 protection tubes. If all 12 positions are used, a second jumper protection kit can be installed as required. When an optical splitter is used, place and secure it in the designated upper or lower section of the splice tray, as shown in the video. The next improvement is the Internal Cable Sheath Holder. This component securely grips the cable sheath to prevent the cable from moving or being pulled out of the entry port. It provides an additional mechanical fixing point inside the closure, ensuring more stable cable retention during installation and long-term use. After inserting the cable through the entry port, position the holder at the end of the cable sheath and secure it firmly. Once the holder is correctly installed, proceed with the heat shrinking process. The internal cable sheath holder is supplied with removable adapters for different cable diameters. Two adapters are initially installed, one in the upper section and one in the lower section. For cables with diameters from 9 to 13 mm, use both adapters. For cables with diameters from 13.1 to 17 mm, remove only the upper adapter. For cables with diameters of 17.1 mm or greater, remove both the upper and lower adapters. Always select the correct adapter configuration for the cable diameter. An incorrect adapter combination may apply excessive pressure to the cable or may not provide sufficient retention. This could result in cable movement, deformation, or optical loss. Next is the cable spool. It is larger than the previous model, providing more space for cable slack while maintaining the proper bend radius. Route the main and branch cable slack around the outside of the spool. Wind any additional slack around the inside and secure it with cable ties. Next, Let's look at the improved cable entry structure. The cable entry ports of the SD506A are longer than those of previous models, with additional grooves to improve workability, heat shrink adhesion, and cable retention. A cutting guide clearly indicates the correct cutting position and helps produce a cleaner, more consistent cut. Two recessed bonding grooves provide additional contact areas for the adhesive inside the heat shrink tube. As the tube shrinks, the adhesive fills these grooves, improving cable retention and sealing reliability. A separate fixing stand also prevents the closure from rotating during cutting and preparation, allowing the installer to work more safely and accurately. The hanger system supports both aerial and underground installations. Two aerial hanger sets are available. Set A includes large and medium hangers, while Set B includes medium and small hangers. An improved manhole hanger is also available for stable underground installation. So far, we have reviewed the main structural improvements of the SD506A. Because the new model includes several redesigned components, installers should not assume that every step is the same as the procedure used for previous models. Cable entry preparation, adapter selection, installation of the internal cable sheath holder, cord protection tube routing, heat shrink tube heating, and hanger attachment all directly affect installation quality. Now let's review the most important installation requirements, step by step. After cutting the cable entry port, the surface must be sanded. If the surface is too smooth, the adhesive inside the heat shrink tube may not bond sufficiently during heating. Sand the entire surface evenly, as shown in the video. The objective is to create a uniformly rough surface that allows the heat shrink adhesive to bond securely. Make sure that all areas covered by the heat shrink tube are properly sanded. Uniform surface preparation helps improve adhesion, cable retention, and waterproof sealing performance. After sanding, completely remove all dust, particles, and foreign material before installing the heat shrink tube. After inserting the cable through the inlet port, check the cable diameter and select the correct adapter configuration according to the installation manual. Position the internal cable sheath holder directly against the end of the outer cable sheath and secure it firmly. Make sure the holder is properly aligned and that the cable is not tilted or twisted. Next, place the holder into the designated mounting position inside the closure. Position the central strength member at the TM fixing point and tighten the bolt firmly to prevent movement. The holder and the central strength member clamp work together to improve cable retention. Before proceeding, check the adapter configuration, holder position, cable alignment, and fastening condition. Insert the heat shrink tube in the direction indicated by the arrow. Position the branch clip at the center of the tube and push it firmly down to the bottom. Using a heat gun or torch, begin heating from the bottom and move slowly upward. Continue heating until all white indicator spots on the tube have disappeared. When heating is complete, a small amount of adhesive should be visible at the upper edge of the tube. Do not heat too quickly, as the adhesive may not melt properly. Before continuing, make sure the tube has shrunk evenly and the adhesive has fully melted. Secure the main cable units in the outer section, leaving the inner sections for the jumper protection tubes. Install the optical splitter in the designated position. Before routing fibers between splice trays, check the length of the supplied cord protection tube. Cut the tube to the appropriate length according to the actual fiber routing path. After cutting the tube, insert the fibers into the protection tube and organize the routing path. The cord protection tubes must be secured in the two inner fixing sections of the splice tray. These positions are marked jumper tube on the tray. Use these markings to identify the correct installation locations. Organize the tubes sequentially from the bottom upward. The cord protection kit can secure up to 12 protection tubes. Do not cut the tubes too short. Leave sufficient extra length so that the tubes can extend naturally below the splice trays without excessive bending, pulling, or tension. After organizing the tubes, close the cover of the cord protection kit. Make sure that the cover opens and closes smoothly without interfering with the tubes or other internal components. After all internal work has been completed, install and lock the closure clamp. Select the correct hanger for the installation environment and attach it to the closure using the mounting bolts. Depending on the site conditions, install the closure on a messenger wire or inside a manhole. Check that the closure is securely supported and that all bolts, clamps, holders, and covers are correctly fastened. Complete a final inspection before finishing the installation. This concludes our introduction to the main improvements and installation procedures of the SD506A. The SD506A was developed to improve the installation efficiency and maintenance accessibility of conventional dome-type fiber optic splice closures. The internal cable sheath holder provides additional mechanical cable retention. The jumper protection kit creates a more organized and consistent fiber routing path between splice trays. The improved cable entry structure helps simplify port preparation and provides better contact between the heat shrink tube and the cable entry port. The redesigned clamp and hanger mounting systems also make installation and maintenance more convenient. To achieve the intended product performance, always follow the specified installation manual and work procedures. Pay particular attention to cable entry sanding, adapter selection, internal cable sheath holder installation, cord protection tube routing, and heat shrink tube heating. Before moving to each subsequent step, carefully check the position and fastening condition of every component. Correct installation is essential for maintaining cable retention, waterproof sealing, mechanical stability, and long-term optical network reliability. VISSEM Electronics will continue to develop reliable fiber optic connectivity solutions designed around real-field requirements. Thank you for watching.